In this video, we are required to find the length x, but using Stewart's theorem. I know there are other ways you can do it, but we have been told to use Stewart's theorem to solve for x. Now, according to Stewart's theorem, so if you have a rectangle of this nature, a triangle, where this is A, B, C, and this side is M, this is N, and this is D. And this side, the opposite side of A is small a, opposite side of B is small b, and opposite side of C is small c. Then MB squared plus NC squared is equals to AD squared plus MAN. So this is Stewart's formula. Now focusing on these side lengths that are going down, this side C, side D, and side B, we can see that in our formula, they are all squared. So this B is squared, C is squared, and also D is squared. Before we go any further, let's first of all prove this Stewart's formula, why it comes to this. So we're going to use the laws of cosines, okay? So the law of cosines, which is a squared is equal to b squared plus c squared minus 2bc cos alpha. Then b squared is equals to a squared plus c squared minus 2ac cos beta. Then c squared is equals to a squared plus b squared minus 2ab cos theta. So this is cos alpha, cos beta, cos theta. Let's say this point is D. Now if we are to focus on this triangle ABD here, if this angle is alpha, okay, then we would have this C will be, so C using cosine law, C squared will be equals to M squared plus D squared, okay? So this would be M squared plus D squared minus 2MD cos alpha. So let me call this equation 1. Then if we are to focus on this triangle ADC, okay, let's say this angle here is beta. Then to find this side B, so B squared will be equals to N squared plus D squared minus 2ND cos beta. Okay, so in triangle ADC, our B squared will be equals to N squared plus D squared minus 2ND cos beta. Let this be equation 2. Now, as we can see, this angle alpha and angle beta are complementary angles because they lie on a straight line. Sorry, they are supplementary angles because they lie on a straight line. They add up to 180 degrees, okay? So alpha plus beta is 180 degrees. Also, remember that cos alpha plus cos beta is equal to 0. And therefore, cos alpha is equal to, when this comes this side, becomes negative cos beta. So if we are to replace this for cos alpha, we put negative cos beta in this equation 1, then we would have c squared being equal to m squared plus d squared minus 2md. Now instead of cos alpha, we are going to put minus cos beta. So minus cos beta. So this is c squared is equal to m squared plus d squared. So negative times negative is positive. So we shall have plus 2md cos beta. Let this be equation 3. Now we can notice that the last parts of equation 2, it's minus 2nd cos beta, and the last part of equation 3 is plus 2md cos beta. They're almost similar, just that here we have n and here we have m. So what you're going to do, you're going to multiply equation 2, this equation 2, we're going to multiply it by m, and multiply this equation 3, the whole of it, by n. And we come up with mb squared is equals to mn squared plus md squared minus 2mnd cos beta. So then also equation 3 becomes nc squared is equals to nm squared plus nd squared plus 2mn d cos beta. So what you're going to do, we're going to add these two equations. Okay, so when we add these two, we shall have mb squared plus nc squared being equal to mn squared plus nm squared plus md squared plus nd squared. As you can see, this is minus 2mn d cos beta. This is plus 2mn d cos beta. So these cancel out. This plus this, they cancel. We are left with 0 here. So this is what we get. So we factor out the like terms. So here we shall have mb squared plus nc squared being equal to, here we have mn and also here mn. So we factor out mn. This will be, here we shall be left with n plus m. Then here d is common, we factor out d squared. So d squared into m plus n. Now from our triangle, we saw that n plus m, from here we see m plus n is equal to side BC, which is represented by small a. So m plus n is a. So since n plus m is a, so this is a and this is a. So we shall end up having mb squared plus nc squared being equal to mna plus, this is d squared a, okay, which is mb squared plus nc squared is equal to man plus ad squared, just like we had stated our Stewart's formula. So this is the proof for the Stewart's formula. Now that we know where our formula is coming from, let us apply that to this figure to find the value of x. So if this is our A, B, C, and this is D, okay, so this side, according to the previous diagram that we used to prove, this is M, this is N, this X here is D, okay, the opposite side of B is B, opposite side of C is C, opposite side of A is A. So we have these values here. So replacing in this formula here, we shall have our M. So before that, according to our diagram, D, instead of D, we are going to put X. So we shall have MB squared plus NC squared is equal to A and MAN plus A, here it will be X squared. So our value, so since we are looking for X, we make this the subject. We shall have AX squared being equal to MB squared plus NC squared. When this crosses, it becomes minus MAN. So we divide both sides by A. So by A, by A, by A, by A. This A cancels with this A, and also this A cancels with this A, and we are left with X squared being equal to, now as you can see here, A, the denominator is common, so it will be MB squared plus NC squared over A, then minus MN. Since we already know the values representing these figures, we shall have X squared is equals to, our M is 14, so 14 times, our B is 20 squared, then plus our N is 7 times, our C is 13 squared. This is over A, which is M plus N, which is 14 plus 7, and that is 21. So this minus M times N, which is 14 times 7. Okay, so X squared is equals to 14 times 20 squared is 400 plus 7 times 13 squared is 169 over 21 minus 14 times 7 is 98. So this gives us X squared as this times this is 600 plus this times this is 1183 over 21 minus 98. X squared is equal to 6783 over 21 minus 98. X squared is equal to, this divided by 21 gives us 323 minus 98. X squared is equal, when you subtract this, you get 225. So since it's x squared, to eliminate the square, we shall find the square root on both sides. And so x is equal to, square root of this is 15. So it's either plus or minus, but since x represents length, which is distance, it cannot be negative. So we consider the positive. So x is 15 units. So that's how you solve this for the value of x using Stewart's theorem. Thank you so much for watching. Please do not forget to subscribe to this channel for more amazing videos. Like, comment, and share your thoughts about the video in the comment section down below. And share the video with your friends and family. Thank you so much. Let's meet in the next one.